So what was the deal with the pizza? They text.
Can everyone hear me okay?
Sorry, Guru, I've got your streaming on here. All good.
Thanks everyone for coming on a Friday. Now I'm muting here. Give me 2 seconds. Technology. Alrighty. Yeah, thanks everyone for coming on a Friday. We're quite surprised at such a big turnout on a. Sorry, there's people waving back there. I don't know what they're waving at. On a Friday, it's really good. First of all, thanks for Insight for sponsoring tonight. Where's Sean? Did you want to say anything? Or you say something when you're talking? Sean doesn't want to say anything. Yeah. Thank you, Insight, for the beers and sponsoring the room itself. And John is trying to sort out the pizza right now. So we may do an intermission after Guru to go get pizzas, but there are drinks at the back. So we do apologize for that. We do have 2 talks tonight. One's by Guru from Westrac. He's doing a talk on their journey in the data lakehouse. And then we have Sean, who's hiding over there and doesn't want to speak, on generative AI in the landscape of data engineering. And then we do have networking at the end, but we have to be out of here at 7:30. Already done introductions, so I'll skip this slide. Now, we mentioned this last time, so if you didn't come to the last talk, Data Engineering Bytes is a conference that's in my eyes, which has been going around Australia for, I think, 3 years now, and it is coming to Perth this year. It's going to be at the Carlton Ritz. Early bird sales for tickets are now on, so please, if you can't see this, or just jump on to Data Engineering Bytes and grab some tickets. It's going to be a good event. We don't know who the actual speakers are at it yet, but if you do want to speak at it, please reach out to John or myself. It is an industry event for the industry, so we want to hear people from the industry in Perth talking, but we will be flying people in to speak for it as well. And thanks to Insight again. This is usually where I ask the sponsor if they want to say anything or if they're hiring or anything like that. But yeah, Insight are always hiring. But thanks, Insight. That being said, I'm going to ask for our first speaker to come up, which is Guru. Hopefully we don't have.
We'll move this off to the side.
Oh wow!
Yeah, just don't want you to.
Sorry, everyone. We had this issue before.
Hey.
Okay.
Alrighty.
Sorry, Kuri, you want presenting your screen on the live stream as well?
Yeah.
Sharing your screen. Thanks, mate. Let's select the screen first. Yep.
Good now?
Yep, all good.
I can talk like that.
You can take it out, it's easier. What do you prefer?
Hello everyone. This is my first ever presentation, so I'm pretty nervous. So please don't throw egg at me. Right, so I'm Guru Prasad. I'm the data analytics manager with Westrac. So I'm going to present today the journey that we have taken with the Lakehouse solution. There are certain things that we have deliberately masked and removed the name out so that for the confidentiality reason. But overall architecture, it's like more of a generic, and some of them we have used it. Okay, so what we have is an introduction, and we're going to talk about the introduction to our Lakehouse and benefits of our architecture, the demo, and also any question and answer. So, yeah, this is about me and my family. I have 2 great kids. I have 2 daughters and happily married for maybe 14, 15 years now. I have 14 years of experience in overall the data space, for 6, 7 years into Azure and the Lakehouse and all the new stuff. So that's about me. So let's see the evolution of how we started. So when we started in 2020 is where we had a data warehouse, a normal data warehouse using a SQL Server. And that database had a self-service. We had a lot of data ingesting directly from the source, and not much of a modeling was done. So that's where we started. And we started using Power BI to do all the modeling and building the solution. So that's when we moved from 2022, where we needed a capability for the data science, and so we didn't want to have 2 different silo created. That's where the Databricks helped us setting up those things. So now we had our first data science machine learning capabilities we implemented for our oil lab, where we do the classification of the models. Previously, all the people used to do like manual classification. Now we're using the machine learning. We have implemented it, and now it's 50% of the oil samples are now going through the machine learning. That's one of the pretty significant project using the Databricks. And we come to 2023. Now,
Guru, do you want to pick up the microphone?
Yeah, sure.
Yeah.
Can everyone hear back there?
No?
Yeah.
You can just pull it out. Yeah. Yeah.
can you hear me now?
Yeah, that's better.
Yes. Yeah. Sorry, I was looking for a spot to jump in.
Okay, so now we're in 2023, where we're looking to more of a modern Lakehouse. That's where we started the journey for the Lakehouse implementation, Unity catalog, and data quality. We're looking into more of a live stream. We're enabling near live data ingestion. And 2024, we know that it's all AI, because everybody is now on the open AI, and if you're not using it, you're going to lose it. So we are, in the future, it's going to be more of AI, and the platform should also support the implementation. All right, so these are the benefits, some of the benefits that we got from all 3. We have tried all 3, the past, present, and the future. So that's a good thing about it. So when we started this in 2020, so the initial warehouse did support us creating 2,000 plus reports, where we had 0 to 2,000 reports within 1 year. So, and we replaced the legacy system where everybody was connecting directly to the legacy system and connecting to the live system and bringing the live system down. So this was, we took out that pressure from the production systems. And we had one structure where everybody can connect to. So we call it as Captis. And move forward to 2023, now we got, it is a lake house as well, but it is not into full-fledged lake house. So we have 30 different sources of data ingested, and I said 30 different. We got 8 to 9 different types of data source itself coming. And we also have, we can write now Python code, Spark, or anything. Now it is code agnostic. And we also reduce a lot of cost there because we're not running the SQL Server 24/7. Now we are running only when it's required. And also the SQL, Databricks SQL enables the user to have a similar experience of a SQL Server database. And we also have machine learning implemented it. And the future is coming where we're using it for one source of truth and also adding a data catalog where we can see the visibility of where the Unity catalog is coming in. Also, we're trying to see a proper industry level catalog like Malaysian or Atlan or any of those things. So we're looking into that option. And also we're implementing the data quality framework where we're using the DBT or upgrade expectation, any of those DBT expectation as well. So you can use those tools for us to do the data quality checks as well. And also we cannot forget the LLM's possibility of using in the future. So this is actually, there are a few things that we have not really mentioned, but these are the type of sources that we have, like a file, streaming, semi-structure, like APIs, XML, REST APIs, and relational databases. And use Azure Data Factory and change data capture using a different tool. And we have Databricks and DBT as in twin. We're using DBT to get the data from the landing zone and then transforming it to bronze to silver, and then using the Databricks analytics for people to use it for anything in the gold layer. And we also have people accessing the silver layer for the machine learning and also for the great expectation to look at the quality of the data. So from it also gave us thing to virtualize the data because not everybody could get the data from the SQL analytics. When you want to share for the company outside the company or to somebody else inside the company, you can still use it. People can use it. Python to consume the data and Power BI. And also we have few shared data model using the Power BI data set where we create a particular data set for a business use case, and then people can build the reports on top of that. If you see the underlying thing where we have, we use Azure Key Vault, Azure DevOps for the code and the CI/CD, and data catalog is coming. And then the usual Azure Monitor and the costing as well. One of the biggest thing in the Westrac is that we wanted to have a decentralized model where not everybody, we're a very smaller team compared to, we have 5 full-time developers for supporting 4,000 employees. That's quite, we never get to do everybody's request. So what we did is, this is a model where we have Gartner's things, where it is, we're giving the access to people to straight away to our lake house, and they build their own pilot. So this way, we're not waiting for them to come to our central team. And out of, we got 50 analysts around the around the company who are actually self-sufficient, and they can do, if we give them the good quality data, they can build their own solution. So we're enabling them to now get the data from what we have. They can choose how they want to build it. And mostly, like out of 100 solutions which they build, maybe 10 might come up like a good quality solutions where everybody started using. So that's when we go to from prototype back to the production layer, where we go back and we have like a CI/CD implemented quality and the modeling and everything. So that way we're getting the right production into 2 different layers. So business knows that, okay, you don't need to wait for the central team. You can start developing it. It has a value. Then we move it to the production after this. So this is applicable for all the solutions, whether it's Power BI or machine learning or any of those things. So you can use this as a model. That's what we use. And have a demo. I said demo, I'm not going to run anything. I'm just sure what we have done it. All right, so this is our data ingestion. We use Azure Data Factory.
Mirror the screen share or something.
Yeah.
Sorry, Guru, you might have to mirror the screen share. I think right now it's just presenter mode.
Can you help me here?
Yeah. Project. Here we go. Project. Back here, we exit this. Okay. Yeah. Good to go.
Okay, so we got this pipeline setting up where we are running those. So we got each pipeline one pipeline for each type. So if I'm ingesting API, we're using the API master going from there. We have type is SQL, then we're using that, and we're using a file system. So we have different pipelines for each file type or the system type. So we got SharePoint, Azure SQL, and on-prem databases. This is where it's called, and once it's called and we landed into the landing zone, that's where we use a Databricks, and we build something like this. So that's the first layer. You can see the bronze and all these tables we have created. So I'm not going to show the data, but you can see all this, the history, the lineage, and everything, and it's all in Unity Catalog. So the bronze layer has like it's a copy of source, exact copy of source, not much transformation done. That's why we have a silver, where we have the transformation done, clean data, and it's ready for usage for data analysts or data engineers. And and we store everything into the ADLS, so that we can use it in any other tool, not just in Databricks. And we go to also have final, which is the gold layer. So where we're using, this is where the dim and fact tables comes in. We create all this. This is for the final users to build the reports of any other analytics they want to do. I'll also show you how this lineage works using the DBT. Yeah, look at this. Sure. Using the DBT for the transformation, so I can see there's a lot of layering from one place to another. So from bronze to silver to the gold. And you can see for each node, we can see what type of lineage it is and how it's been connected to each other. So, yeah, and this is the final product, and then using this you can consume using the Power BI reports. And back to the demo here. Right, so what are the lessons that we learned from last 4 years of this? So we always think that the technology and then the use case, always look forward, understand what business needs, and then build the technology on top of it. The benefit of that is because when the business sees that there is a benefit in it, doesn't matter how much it costs, they are ready to invest in it. So always remember, when you have that, show that value, doesn't matter how much it costs, if you show them the benefit and the cost value, they're always gonna buy it. And because the landscape is always changing very, very fast, and even we learn, so we're gonna always keep the architecture adaptable. The new things are coming much faster than we anticipate, so you can't make it very rigid. You have to keep it open. All the things what we learned is all good when 20 years back, 10 years back, but now you have to be very adaptable and agile. And also, when you're using Azure or any cloud solutions, keep an eye on cost. It can blow up very, very fast. So you have to make sure that you have the monitoring and keep an eye on cost. And we have empower business users. So if you don't empower the business users, understanding what is the capability of it, they'll not know. Doesn't matter how complex your solution is, and if you're not really communicating to that, because we as a tech team never do that. We build and we're happy with that solution. But if we have to, that's what we learned, that we have to empower the business so that they know that what is the capabilities, and they can always come back to us and enabling themselves, not just a central team. They can be self-sufficient as well. All right, so it's the time for question and answer. Anybody has any question? Yes.
Hi, how long does it take to add a new source to your framework?
It depends on what type of source. If it's like SQL Server or something like a structure, then we would say within a day. If it's like an API, then depends on what type of API it is, and we need to look at the pagination, and depends on how complex is that. So if you're using an ERP like an SAP, so then you need to see what type of connector you're using. So it all depends on once it is set up, then it's quite easy. Let's say we set up something for the API is something different. You can't say that one setup and then everything one setup and everything is going to work. No. So yeah. So for something that is structured, you know that this is how it's going to come. We can always. That's how we have 4 type of source types pipelines, where you can set it up one and you can keep adding. Adding a new one is going to be like 10 minutes. You can still 10-15 minutes. You can say all the structure is there. Then we don't need a lot of time.
Thank you.
I have a question.
Yes.
You mentioned self-service. You get the business to get into it first. Once they've reached the production point, who owns it? Does your team own it?
Now they are the owners of the quality of the data, or we are the owners of the solution.
Yep.
But we never own the
Right.
solution. We never really own the product that they built.
Right. So once business value has been confirmed,
Yep.
it's handed over to your team.
Exactly. So it is, we maintain it, but if they say, okay, why is it showing 50 million or 60 million, then say, okay, business, you need to look at it. So we can build that.
And my second question is, how many Unity workspaces do you have? Are you just running on the one right now, or?
Now, Unity, I think we have 2. We call non-prod and from the catalog, 2
Yeah.
catalogs. One is the non-production and the production. We have 2.
Okay, cool.
And we use like a staging thing where for people can play around. We have a database which is dedicated for the playing around for the sandboxes. It's connected to the production database. So you play around, do whatever you want there. Once the solution, we know that, okay, people are using it, and we take it from there and put it into UAT, we test it back. It flows through that. Yes.
Great presentation. A question around data cataloging. So from a self-service perspective, how do your users know what's available in the warehouse? Do they find out from the Power BI data sets you publish, or do they have access to the Databricks platform?
Yeah, so that's one of the tricky questions, right? So anything which is in the Databricks, we can still enable through the Unity catalog. They can see what we have, like the DBT DAG. You can search what is available. However, that's only restricted to that particular technology itself. Let's say if somebody wants to know what the reports are there, they still has to go to the report, like a Power BI, and search there. So that's why we are actually looking for a data catalog solution where it can surface from every technology and join it together. So yeah, it depends on the business case how well, because we've got a lot of users, and that's why it's solution box. Otherwise, we don't need that.
Could you speak to your decision around using DBT versus just Databricks and how you found that experience?
Yeah, I think the DBT, I can say the Databricks is pretty good as well. Just that the DBT has got, because it's more of where it automatically, you don't need to use the DLT, because the DLT, when we tried to do the DLT and the DBT before, there was no option for us to do the functions. Let's say if I create a function where I can reuse it, I have to write all the time. I have to write the transformation when I'm doing it. Now they have come up with that, but it's already too late because we moved on to DBT, and it's much cheaper as well because it uses DBSQL, where in the DLT uses, I think their cost is a little more.
What is the frequency of backing up the data in a high availability server? What is the frequency of backing the data in a high availability server?
So we, when we say backing up, because all our data is stored in ADLS, and that has got the backing up. So any kind of delete happens, so we have the cover for that.
Hi, you have bronze and silver and gold. How do you define when you go from bronze to gold, silver and to gold? Is it data quality, and how do you do data quality?
Right. So the data quality is usually done on the silver. So we look at the silver and see what kind of transformation we need to do. Do we have to do like a trim or change the dates to whatever the string or all that? And then we have a data quality tests on that before it goes to gold. And we have another table that actually says, okay, this is supposed to be not null. I see it's null. So we can't say what do we do with that. So what we do is we put it in a different table. In the gold, you can choose, depends on what the business case is. Business says, don't worry about it, bring it whatever it is, then we'll fix it later. Then we leave it. Or they say, no, it's not supposed to come. Then we join the table to the actual table where it is there, and we say exclude that. And we also send that error table back to the user saying, now we've got to fix this, so that when the next one comes in, we don't see that error coming back.
Just adding to that, what level of manual or no intervention is required in maintaining the cleanliness of data through gold, silver, and bronze?
I think once you define those rules, then it's going to be, we don't need to touch anything. So once the rules, that is the most trickiest part. That's the most difficult part, is always defining what rules should we apply on what. Because you don't need to clean the data unless you really need to, because some of the tables has like 200, 300 columns. By the time you clean, where 99% of the time people only use 5 of them. So why spending time on all that when people aren't using it? So when we try to build something on the gold, we can know, okay, I'm joining this, I see there's a problem with the data. And that's where we go and clean it, and we apply that for, if there is a common trend in it, we say, okay, let's apply this rule for everything, because I see this is a problem everywhere. So based on that, you have to define the quality. Quality is always, some source systems are great quality, you don't need to do too much. like an API, anything coming from the REST APIs and those things are quite good. The naming conventions and everything's are good. Some sources are like the one we use at DBS. It's very, very bad to use it. So, any questions? Yes.
Another one.
Yeah.
So, where does your job stops? Basically, where self-service starts, and where is it? Do you stop your work at the I don't know, dimensional at the model level, or do you stop your work at data flows level? Like where?
No, we don't stop anywhere because we have different section that we always have something to be productionized or something to be built by us, our team. And so there's a very high value solution that we build. It has to be built by us. So it will go from the top layer. I will be still building the goal layer for that particular business use case. And if that use case is already suiting for analysts, we can say we build it for somebody else. Well, use it, you can use it. Otherwise, you build on your own. And then if we think it's all good, then we incorporate it to our solution as well.
And another one for you is what tool do you use for self-service? Because I saw Tableau on the screen.
Yeah, though that is we don't use Tableau, but
Use Tableau.
I'm saying you can use any tools to surface the data. It's a consumption. We're just saying generalizing. So we use Power BI for the reporting. Some people use Excel, which is very you can connect directly to use, and also use Python. There's certain they're good in using Python, so they use Python.
Thank you.
Everybody uses.
One more question, if that's all right.
With your Power BI self-service model, you use one single workspace and all your analysts are contributors in that same workspace for visibility, or are you providing each analyst their own workspace?
Now, what we have, the structure is like we have for each domain, for example, finance is a domain. So we have two workspaces, one for enterprise finance, which we built. Another one is, we call it as test operations or something, we can call anything. So that is the dedicated for them. We're not responsible for that. Anything is there, so we're not responsible for, when I say responsible, they can't delete or do anything. It's just that they can do the publishing and share it with their users. So they have complete freedom on that one. So we don't really restrict too much on that.
If you have any more questions, you have a question?
Yeah.
All good?
So usage matrix, I know in the Power BI admin console, the reporting there is quite not so impressive. So how do you get visibility of the usage of reports across the organization as well as the data sets to know which ones are being used and which ones are stale? How do you do that?
So we use that every 6 months because when we say, you can see that we have 2,000 reports.
Yeah.
If you don't clean it, it's going to become 20,000 within some time. So we do the cleanup every 6 months. So we have APIs that calls and stores the logs. So you can call it through Azure Functions or any of those things. It's pretty easy. So you can keep that data, and then it quite tells you that who's using and what functions they're using. We also use that for people to give the pro license as well. We don't give everybody pro license. So we know that, okay, how much, who's using and what is he using it for. So, yeah. All right, thanks everyone.
Thanks, Guru. Your first talk, it was really good. I think it's the most questions we've ever had. So I think that's a tell sign. We're going to pause for 10 minutes and get some pizza, and then come back to the talk. Yeah, no complaints. going to sit on the chair. Hello. Sean's going to project his voice, but I just want to thank Sean for coming in on a Friday. He's going to give a talk on generative AI and data engineering.
Yeah, that should be fine.
I'll just leave it here for you.
Feels like I'm open mic night. Oddly familiar. Okay. You guys can hear me okay? All right, cool. All right. Brief introduction since we didn't get to that. Yes, we used to do that anyway. I've been working at Insight for about 6 years. I've been in academia for about maybe 10 years in parallel. And for Insight, I lead the data science team for WA and several other regions as well. Quick disclaimer before I begin, I do tend to go into lecture mode in my seminars. So if I actually accidentally treat you guys like students, I'm sorry, because I tend to, give too many lectures. So anyway, let's get straight into it. I will try not to go too fast as my normal speed since I'm full of booze. But yeah, so basically the talk that I'm going to get today is a very general overlook on generative AI and how it relates to data engineering. The topics that I will cover will be introduction to generative AI. I'm going to call it Gen AI from now on because it's simpler. And I'm sure that this being a data engineering meetup group, most of you will be quite familiar with how Gen AI works. But for the benefit of those that don't, I will go through some of the common models and some of the key components that make up a Gen AI architecture. I will also go through the topic of the talk today, which is synthetic data generation and code generation, and also go through some of the challenges of Gen AI in general. So to start with, what is Gen AI? Gen AI is basically a model that generates realistic content, right? So you have your natural language, you have code generation, you have generating images. There are many, many different types of Gen AIs in OpenAI umbrellas. But most of the time, this is the general framework of how it would work. Now, the training data in any kind of machine learning or data science context is always going to be the most important. Now, understandably, that even though it's supposed to be in a data engineering context, the nature of my work in data science leads me to go towards a data science context. So it might sometimes in my talk veer back towards a data science context. Okay? So yeah, I'm not gonna explain the whole thing again. You can see for yourselves. But in a general architecture, this is what it would generally look like. Now, before I move on, do you guys have any questions on this? All good? Cool. All right. So a bit of a history on generative AI. The evolution of Gen AI. So on the left, on the axis, you'll see the number of parameters, millions of parameters, right? So the evolution of Gen AI basically starts from the first ChatGPT model and going all the way to GPT-4. And you'll see the exponential increase in the amount of parameters, right? What does this mean? This basically means that one, if you need to retrain an Gen AI model, it takes a hell of a long time. Okay? It takes an extremely long time. It's resource intensive, which is why it is worth training a model, but you have to balance your cost versus your value resource of that. Okay, so this is the evolution. This Megatron tree here, that's insane. Okay, I saw that before. And it's absolutely insane. But this is the general ChatGPT tree dataset that they use. Okay, it's massive. So anybody that creates a neural network, and anybody that's dealt in recursive neural networks, convolutional neural networks, will understand the amount of data it takes, and this blows it out of the water. Okay, so that's why it's cost intensive, resource intensive to retrain a model. That's why it takes a while. Okay, so some use cases, as we mentioned, You can see for yourself, but what we're going to go through today is basically data generation, which is synthetic data, and also the code generation, which I will give an example of. Some examples of how it works. This is not an exhaustive list, okay? But basically, this is how it works in essence. You have your chat GPT, which basically produces a natural language response. You have your prompt here that allows you to create queries, which I will give an example of later. And DALL-E. GPT-4 also allows you to do this right now, right? So that's under the GPT-4 remit. Creates an image. It's a very weird looking cat, by the way. No offense to cats. It's staring into my soul. Okay, like I mentioned, the Gen AI architecture. So a Gen AI architecture is important to understand in terms of engineering as well, because you want to know how it works. You want to know what components it's made up of. You also need to know the cost, and you also need to know how it works in a general enterprise architecture as well. But basically, again, it's an adversarial network. In short, it's basically putting two neural networks against each other and trying to determine whether or not the information generated by one neural network is relevant or not. Next one would be the encoders. Okay, it's a compressed representation and it uses a latent space, and it works slightly different to the encoder to the adversarial networks, which I'll explain in a bit. So the key components here. Sorry, am I going too fast for anyone? Anyway, all good? Okay, cool. So the generator, okay, is, as mentioned on its name, it generates the content, right? This is specifically for GAN, okay? It works by putting its content against the discriminator, and then it produces a loss function. Now, if anyone's familiar with machine learning, a loss function should be quite familiar to you. But basically, a loss function is the amount of error. How far are you away from the actual? Right? So if the discriminator cannot discriminate between cannot identify a far enough error from what your generator is producing, it assumes it is correct. A bit of a problem there, which I'll go through a bit later as well. Okay? So now the encoder is slightly different. So you notice that one of the main difference it has is, apart from loss function, it has the encoder, decoder, and it has the latent space as well. So what it does is that it produces a contextual specific space based on the features of the input data. Do we all understand what features are in this case? We all good? Cool. So it basically creates a feature list, right? And then it puts it into the feature space, and then it creates those outputs based on the feature space, and it compares against the loss function. Okay. So I'm just gonna let's through that. So the next thing that I'm gonna go through is synthetic data generation. It's one of the main users in the data engineering space. Now we all know that we can generate data using Gen AI. That's what the namespace calls it. But then why do we use it in terms of data engineering, or especially in terms of data science? Why do we want to use it? It's because a lot of times data generation and data acquisition in terms of research especially is very difficult. Okay, we don't always have large data sets, especially if you're creating qualitative data sets. Okay, so qualitative data sets is one of the most difficult data sets to acquire because you're running around doing surveys, you're collecting web scraping and stuff like that. But what Gen AI does for you is that it allows you to create synthetic data based on the nature of the data, right? It allows you to create sample data to test your model against. Understandably, that when it's generating data, again, it is not factual data. It is representing the distribution and the characteristic of the data that you're trying to create. Okay, that's where the value comes in. Other users of synthetic data generation. So image synthesis, you can generate images, basically saying, okay, like that weird looking cat earlier. Sorry, it's not weird looking, it was staring at myself. So the cat image or any kind of images. So for image classification, right? most of the time in unsupervised learning, you're not telling the machine what image that is. Sometimes you're saying, okay, I want you to cluster images together. But if you don't have enough images or sample sizes of that cluster, that model is not going to work very well. Okay, so you can generate similar images. Why? Because I want to train the model to look for those specific pixels in that specific area of that picture. And then when it occurs again, I know that that is that image, right? So that's what it does. Text generation, I don't need to explain too much. Upsampling is specifically related to data science as well. So upsampling means what? Upsampling means that if I don't have enough data, again, I am creating extra rows. Previously, in data science, there is a method called SMORE, which is a synthetic method as well. But that is a slower, older algorithm. I won't say slow, just older. Okay, and what it does is it increases the minority data set to give you a balanced data set, or just helps you to create more instances of something that you're trying to target. Right, you're basically increasing the instances of your target variable. So that's basically upsampling as well. Upsampling also works very well in medical data sets. Why? Because you don't want to have patient information uploaded into the cloud in that instance, right? So you can create similar characteristics of patients of certain diseases and use that to train your model. Time series data generation, that is something that is very prominent. The most prominent use case is optimization or telemetry data, okay? Especially in terms of mining. Optimization sometimes, it's not sometimes, it's always one of the biggest use cases in mining, right? So what we're doing here, because the data that we get from experience, from PyHistorian or other kind of source data, isn't always going to be good. And it's also always sometimes going to contain some data quality issues, right? So in terms of engineering that data set to create it for machine learning, time series data generation is brilliant. Because I can just tell the Gen AI to say, can you create data based on this column's distribution, right? Follow the characteristics of several columns and several characteristics of data based on its summary statistics, okay? And give me additional 1,000 rows, okay? And give me, and split it by hour. So basically that is very useful when you're creating telemetry time series prediction for maintenance and digital twins. Okay, digital twin is one of the big things as well that Gen AI really, really helps with. The next one will be, and certainly not the least, is data augmentation. So basically, you can actually tailor synthetic data based on real audio data. So one example is like you use, you get audio data, which has the frequency, and you want to go like, okay, I need to make sure that it augments and fits within a certain criteria so that I can train a model based on those characteristics. Because you're not always going to get clean data. Again, it comes back to the quality of data and how much data you can acquire, right? So basically, I'm saying, I've acquired real data. What I want to do, I want you to modify this data. A simpler example is saying, I want to reduce the standard deviation of this column to a certain range, okay? And I do that. I want to normalize this data in a certain range. Okay, I want to regularize this data in a certain range. It does that for you, okay? Now, the next one here is code generation. Now, before I go on again, I know there'll be time for questions later on. Any questions thus far? Yes?
How reliable, from your experience, how reliable is the
Okay, depends on the level of fault tolerance that you have, okay? I'm going to go through that in a bit, but reliability is really based on your fault tolerance. Depends on what you're asking as well. If you're asking for sampling data, then your fault tolerance will be higher. If you're asking for factual data, then your fault tolerance will be less. It is up to the user to determine what kind of question they are willing to have that fault tolerance on. Okay? Cool. Anything else? Yes. Matt.
By its nature, synthetic data would not have outliers because you're sort of smoothing out and
Yes and no. Yes and no. Yes and no. So what's happening is that if you are creating synthetic data and you're using, you're not creating any criteria. I say, look at this set of data, create more data. It will overfit.
so it will replicate.
It will overfit. Yeah, it will most likely overfit data in outliers. You're not expecting outliers, but because an overfitting model will include outliers, you should expect it. So sometimes yes.
I was worried about using clinical medical data and then creating.
Yeah.
So there are not patients like that.
Well, the world is big, so, and the part of it, the example that I have is basically on a project that I did. There are some models that I'm going to go through that again, but there are some models that are trained on biased data, and that's the biggest no-no in machine learning, right? You don't want to have a biased data set. So what you're doing is that you're balancing the data set. It could be on nationality, it could be on age group, it could be on income, suburbs, etc. like that. So I'm not actually concerned on whether the person exists or not, because obviously you know it's generated AI. What I'm concerned about is, does that data follow the nature of data previously? If it has the same characteristic, it is a plausible situation, plausible application. So I'm using my model on that.
So just to finish that, what's the gain of creating this data, even if they have the same statistical distribution? What's the use? What's the gain that you have there?
Data collection is easy.
Data collection.
It's the easiest thing. Being in research, like if privacy concerns is a thing, right? A lot of times, the hospital's not going to go like, here's my patient data. You're never going to get that, especially for large corporations, financial loan applications, stock prices, all this. Well, stock prices are a different matter. Loan applications, financial institutions, very difficult to get data out of them, right? So if I can replicate a naturistic data, a similar data set, then my problem is solved. Yes.
So in that context, how do you validate the data you've generated?
You check for distributions. You check for standard deviations. You check for summary statistics, right? And yeah, so basically, if the nature of the data is in its summary stats, right? If it's similar characteristics, then you have about a good confidence level that the validation is correct.
But how do you know if you have a small sample set, like sample data set?
Extrapolation is the name of the game here.
Yeah. Because what if you have a bunch of unique data or outliers that happen to be in that sample you got?
Okay, so then it's a different method altogether, right? So outliers is always going to be a problem.
Yeah.
So are you going to apply smoothing before you do your sampling? Or are you going to include the outliers in your sample? Because like Matt was asking, if I include outliers in my sample, my data generation is always going to include outliers as well. So am I smoothing it out first, or am I not? So if you smooth it out first, that's not an issue. Yeah. Sorry, you had a question?
You were mentioning access to data sets. You don't have access to. So it sounds a bit like a chicken and egg problem. So like, if you don't have access to the data to generate it, how do you create a model to generate data?
Yeah. Most of the time, you can scrape some kind of data, right? So for example, if I'm saying census data, and you do census by disease propagation and clustering, then I can say, okay, based on this census data, assuming that the census data is accurate, fingers crossed, then I can move forward with that. So then I can create a similar data set to that. Because if I'm saying that, let's just say that in the lesser popular eras of history, when things weren't as good, right? It would be predominantly a certain ethnic race that owns land, right? But if I look at the next phase and I say, okay, this is not correct, this is not a representation of what's happening right now, I can tweak it to make sure that the representation of data in my sampling set represents the distribution of ethnicity. So it doesn't mean that because you don't have data, I can't create more data. I can set certain hyperparameters. Hyperparameters meaning the settings of settings, right? I can set these hyperparameters to say, okay, I want to generate data based on these settings because I know that these are true today. Make sense? Yes.
So don't sidetrack too much, but just to make sure I understand this correctly, does this sound like it makes sense? So if I might have a ton of different models I want to train, they're not really good at dealing with small data sets. They can only deal with, they have to have the data there in the first place to train them, right? So I could look for individual models and try and tweak them to work on small data sets, or I could do a pre-processing step to generate the synthetic data to feed those models. Would that be an accurate way to kind of describe this process?
Yeah, you've basically described two methods of machine learning. One is ensemble, and one is synthetic data generation. And ensemble is good. And ensemble means that I'm using smaller models and then I'm minimizing the loss function, right? The only problem with that is that if my error is big, it compounds in the smaller models, and then it builds towards that. So yes, that is a valid method of doing that. Yeah. Cool. All right. So code generation. This is a bit more simple. Basically, I'm saying, okay, based on a large language model, LLMs for short, I'm saying, okay, use natural language to create queries that will be passed into the architecture, and then it returns it passes the query into the architecture, and then it passes the results back into natural language. Okay. So one example of this is something that Insights built. To not make it sound like a marketing spiel, but this is what we built, right? We have built this. So basically what it does is that it allows you to interact directly with the data sources. Think of it as a Azure Purview on steroids, if you will. Okay? So it allows you to use natural language to say, hey, ask me about my data. You know how Power BI had this thing, ask me about my data thing? Those are familiar that it had that little thing. Yeah, it's something like this, but it's using the Azure architecture and ChatGPT. It's incorporating OpenAI into the Azure framework. So basically what it does is this. Okay, it has a user interaction. It starts from the top. It summarizes the input, executes against cognitive index. It passes it back into your data sources. It queries your data source, passes the results back, and then returns it in the data frame and passes the result into natural language. So basically, you ask it, hey, what were the best sellers of this, and it takes that text, converts it into, for simplicity's sake, SQL. Okay, converts it into a SQL statement, and it says basically select top 10 sum sales from sales table where year equals 2020 or 23 or something like that, and then it passes it back, and then it returns the result and it says, oh, the top sales for this year, top 10 sales are this. Okay, that's basically what it does. So, but this really, really helps because it means that end users don't have to be well versed in coding. It doesn't mean that they don't need skills in querying, right? It means that I know what I want, I know how to ask, and I know what I'm expecting. And then they reevaluate whether that result is correct or not. Okay. Some of the potential use cases, basically we have your potential data source, and it basically exposes the end user in these one of these formats. Okay. For those that are interested, this is basically how it would work in a general architecture. It's how it interacts. Ash is just like, I'm just going to point it out here. So, okay. So basically, you have your inside access, right? Your U-class library. It's basically in Python at the moment. Okay. And then it uses the OpenAI context. At the moment, it's ChatGPT 3. And what it's doing is that it's storing the metadata. It's checking the metadata, goes back into the AI service, and then it goes into your consumption. Okay. Internal data source systems. This is missing actually CSV files. It actually starts working with CSV files, PDF documents. Although PDF documents have a little bit of nuance to them, the format sometimes is a little bit wonky. You know how your text doesn't really format really well? Yeah, that's still complicating. Okay? Don't worry about this. So that's the general architecture of how it works. This has been built already and it's been tested. Can't demo it because I don't have access to the GitHub. Actually, I might. Actually, I don't. Okay, the next one is this is something that's quite simple. I use ChatGPT to create a program, very simple program, right? So you're basically using natural language prompts to tell the program to say, hey, I want to create this program, okay? And then it gives you this simple code, and then you refine it, right? So the example is this. I started with this, create a simple lottery program because, that's me. I would have asked it to write a poker program, but I think that might be a little bit more unethical than anything. Anyway, so they said, okay, here, on the left side here, this is a simple program. Okay, sure. I want you to refine it. Put 7 numbers between 1 to 47. If people play Lotto enough, I'm looking at Oz Lotto. Okay? So I said, okay, sure, here it is. So I refine it further. So it generates new code and I say, okay, it creates the range. So you see the difference here? Lottery numbers, random sample, range of 6. Now I change it to 1 to 47, 1 to 48 and 7, right? That's not really things of max value. Then I go like, all right, I don't want to input my own numbers, generate my own numbers because I'm doing a slip pick, right? And it says, okay, here you go. So user numbers, random sample, same thing. And then next one I go like, all right, what are the prizes that I can earn? So I said, just put in all prizes from Oz Lotto. I didn't specify which Oz Lotto, but I assume that there should be only one. There might be more. But I didn't prompt it anything else. I didn't prompt any specific prizes. I just said Oz Lotto. And it said, there you go, prize money. Okay? And then after that I go like, include a profit and loss amount because, it's me again. I want to know how much I win, right? If I won, okay? And then it says, okay, generated a response. And then I said, okay, I want to know how much I would win within a certain number of years, if I would. So I refine it again. So the point so far is that you can use it, but you need to be able to give it specific instructions to refine your code. It's easy to do, but the person that is typing it still has to have knowledge of, in this case, object-oriented programming. Actually, no, this is Python, so programming, right? So you need to understand how ChatGPT or a Gen AI accepts your commands, okay? If I didn't give it specific instructions by bit, it's just going to give me a big mess of code, and it's not going to be very optimized. So built upon the different steps, right? I refine my code in different steps. And then the next one is, you guys want to see how it works? Okay, wait. Let me. So basically, I ran the code. Wait, it's not sharing. Oh no. Can I move this? There you go. Okay, profit and loss over 100 years, $273,000. Okay, bottom line, don't play the lotto. It's pretty bad. And this is based on playing 1 game a week. All right, over 100 years. Okay, and I said, okay, if I win, just roll it over. This is how much. So yeah, I don't think I've ever hit more than 3 or 4 numbers per game. Obviously, you want to refine it further, right? You can refine it even more. Okay, but yeah, the main idea here is that you can use this language model to basically create code that you can refine. It needs to be refined. And if you don't have knowledge of code, you still won't get a good program, right? You need to have knowledge. You need to have data engineering knowledge, okay? And second thing, yeah, don't play the lotto. Okay. So, all right, so next one here. All right, now we move on to some challenges in Gen AI. One, like I mentioned before, the model is resource intensive. You want to retrain something, it takes a really long time. Why? Because you're rebuilding the neural network. Okay, think of it as essentially rebuilding a brain. You're reforming all the connections, the billions upon billions of connections that have interconnectivity with one another. You cannot simply just add a new topic and then connect it again. because every other neuron is connected to neurons before. Okay, so that takes a while. The next thing is that we're talking about bias. Remember I was talking about how if you train a model on a certain data set, and your data set is biased, your model is going to be biased. Same thing for Gen AI. Okay, if you are using only data sources that have a certain characteristic, it's only going to give you results that are going to follow that characteristic. Okay. Yes.
I'm reading that ChatGPT training costs around $4 million.
Yeah.
Microsoft gave OpenAI in 2019 $1 billion.
Yeah.
It's 250 times that. So they could have made 250 ChatGPTs.
No, no, it doesn't work that way. It's like saying, hey, this project is worth $20 million. As a consultant, do you get a part of that? No, I don't. So it doesn't work that way. So cost is not reflective of capability.
It's so little, just $4 million.
Oh yeah. Well, give me $4 million then.
But this, no, today they got 10 billion more.
Yeah.
Okay, so it's pennies.
Yeah, but it's still a substantial amount. Yeah, the cost in machine learning will be exponential. There's no avoiding it. If you're investing in technology, it's exponential. Yeah, there's no going back. If you can, then changing the world.
Are you familiar how these generative AI applications are providing model drift or data drift?
Ah, yes. So, data drift is one problem that we face a lot in machine learning, right? For those that we all know what data drift is.
Drift.
Yeah, data drift. So, how do we check for data drift? We check for the same thing. We check for the distribution. Thank you. We check for the distributions of certain columns, right? That are important to us. ChatGPT works the same as any kind of pre-processing data if you want it to do. Not ChatGPT, Gen AI. Implement checks that go like, if I ever cross the threshold of this standard deviation range, that's data drift. What do? Do I correct it? Do I get more data? Do I generate more data to account for that data drift? But do I need to do that? Data drift isn't always bad. Data drift means a change in the characteristics of the data, in the nature of the data, right? It could also mean a change in the situation, right? It doesn't mean that because data drift is detected, you have to change your data. No, you change the model, right? So you use Gen AI to create specific rules, and I say, okay, if this standard deviation or this range or this distribution goes outside of my perceived range, I retrain my model on the new data, and then I redeploy it. But you can't redeploy it yet, but it's MLOps cycle. So that's basically how you can do. You can use Gen AI to look at what standard deviations are in the range and then account for that threshold. Cool. Now the next problem is hallucinations. Show of hands, are we familiar with what hallucinations are in Gen AI? Okay, cool. At least there's some. That's good. Yeah, of course you are. So, lack of time. Basically, what happens is that hallucination is when the Gen AI model.
Sean, you just go.
Oh, I'm hallucinating.
Yeah, hallucinating.
There we go. Okay. So,
too much beer.
Never too much beer, my friend. So, what happens is that the Gen AI model is going to create what appears to be fact, but aren't actually facts. Okay, why does this happen? Because there's a larger corpus of knowledge that the Gen AI model draws from. And then it goes like, oh, this looks like something to be plausible, there you go. But the problem is that people that are not familiar with how Gen AI works will take it as fact. Right? And if they do that, that is a very dangerous problem. Now, the mitigation techniques are purely in data science methods. So regularization is basically a method of creating a less complex data set such that your eventual model isn't affected too much by fluctuations in the data. Okay, that's the simplest way I can put it. But the main point of this here is that hallucinations are one of the biggest problems Gen AI faces at the moment. An example of this is this. I asked it to create a literature review. Right? Give me a list of references for lit reviews for Gen AI. And the first three it gave, good. It existed. So I did a check. Yeah, that works. That's correct in most spaces, meaning that the authors are correct, the article is correct. Okay. The next one that he gave, you can see that a lot of the examples in the first three one, you got the names wrong. Okay, the names don't really exist. It seems to be slightly biased towards Chinese. I don't know why.
Oh no.
So, these people exist. Okay, these people exist, but they were not the original authors. I did an extensive search based on these article names, okay, and they go like, oh, they don't actually seem to be the authors that created this article, okay, and then I did a check again. The last one I couldn't find at all, okay, so that's something that you have to understand. So the reason why this came about is that this entire presentation I created using Gen AI, but I needed, academia and me, right? I needed to know if they were real. So I double checked my sources. I asked it to cite the sources and give me a list of references that I double checked again myself, and then I realized that these are the problems. Okay, so that's hallucination. Why? There is a multitude of lit reviews out there. There's a big corpus of knowledge out there, and there you have plausible. What was the term? Not deniability. Plausible realism. I don't know what's that word. It's plausible. It's plausible that these are correct. Okay, so you have to use your own research discretion as well. It still needs human interaction. Okay, Gen AI doesn't mean that it's correct, right? You have to make sure that you are.
Especially in this case that they don't access the internet, so they created something, but they should access the internet to see if it's real or not.
Oh well, that's the main thing. Like if you ask anything prior post 2021 for free, then I tell you, oh, I don't know anything in 2003, right? It still thinks the Queen's alive.
Yeah, but these cases are before 2021.
Yeah. So yeah, that's basically the case, right? You have to make sure that you apply some sort of discretion. How are we doing for time, Ash? Am I over?
No, you're good. You've got like.
All right, cool.
5
All right.
minutes.
So everyone's worried. Everybody that asks me about AI, are we at the Terminator stage yet? No, we're not. Why? Because Arnold Schwarzenegger is like 72 years old or something. And also, we're not there yet. Why? It's not sentient. Sentient? Yeah, it's not sentient. The moment we have sentient AI, run. Okay, that's when we have a problem. Okay, but some of the consideration, ethical consideration. What are the considerations here? I mentioned discrimination already. We all know that. Privacy violations, opacity, and accountability. The most prominent one is privacy violations. Why? I can actually use Gen AI to infer certain pieces of information already, right? Whatever that I can find online on a certain person is public knowledge. But I can also use that to infer addresses. I can also just infer past acquaintances, mobile numbers, right? All these kind of things. So that is, in essence, even though it's in a public domain, I don't really want you to know about these kind of things. It's almost a privacy violation, right? So that is something that has to be considered. As an organization, if I'm engineering data based on real people, where does the boundary lie? Where do I stop? How do I protect people, and how do I protect ourselves from litigation? Okay, that's the main thing, litigation, isn't it? Okay, another thing is societal impact. Employer disruption, power concentration, digital divide. The most prominent one will be in the digital divide, because it also applies to the above two. What is the digital divide? So the founders of Google coined a term called digital natives and immigrants. Okay, so digital natives are people who are born most likely after the year 2000, where they never were in a world where technology at its current stage did not exist. You ask them what a pager was, they have no idea. Ask them how they answer the phone, it's like that, right? So digital immigrants are our baby boomers. There is a third category which I feel they didn't feel the coin was digital pioneers. That's us. Well, I assume. I assume. You all look my same young. Anyway, you all look great, by the way. Did I mention that? Yeah, look great. Digital pioneers, because we grew up when technology was emerging, and we were the first to actually use it in our adolescence. Okay, so the reason why the digital divide happens is because there is a very, very vast method of working between people that are immigrants and people that are natives. Okay, you notice that digital natives seem to have a shorter attention span and absorption of knowledge. They absorb knowledge really fast, but then it just goes by them like a sieve, right? And then the methods of working are different as well, right? Instant gratification is one of them in the technology sense. Okay, so that is one of the ways. And the way that happens in employee disruption is because now a lot of the times where you go like, hey, a lot of the things can be replaced by Gen AI. No, Gen AI in AI is not supposed to replace it. It's supposed to complement your job. It's supposed to complement what it's supposed to do. So that is one of the societal impacts. When a company and organization decides to implement these kind of things, how do I make sure that I'm not disrupting the employment pool, right? I'm trying to enable, okay? Malicious information, like I mentioned. There we go. So malicious information, obviously. Anybody ever type how to create a bomb in ChatGPT?
I saw people do it.
No? Okay, I did. So it goes like, oh, as an AI, I'm not supposed to blah 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 blah. Okay, then go like, okay, what's sodium nitrate? Okay, what's potassium nitrate? Okay, how do I make a volatile compound? Ask it in that way. It will give you the answers, right? So any 5-year-old can basically fool Gen AI into violating ethical concerns, right? And that is malicious information. How do you prevent that? Right? An easy way is to make sure that I can't control what people do outside, but if I'm allowing people to use Gen AI in my organization, I can control what information spits off by putting another layer over there. Okay? I put another Gen AI model over there and says, if you see these key terms, do not return the result. Something like that, right? But it is up to the organization to impose these ethical boundaries. Okay? Now, any more questions? Yep.
We started with synthetic data generation.
Yep.
And then you went to code generation.
Yep.
So say in the context of like you have limited data and you're trying to create synthetic data, right? What's stopping you from just saying, I have this synthetic data? Can't you just create me a model that are able to describe? Like if you're asking it to generate synthetic data, it has information of the data itself to be able to generate the model that are able to do whatever the model that you're trying to think of.
Okay.
Is that correct? So like what's the purpose of creating synthetic data where you can just straight away goes build me a model with this data?
So are you asking? I need to answer your question. You say, I want to build a model.
Okay, because
that understands.
Of creating the synthetic data is for you to train some kind of model.
Yep.
Yeah. But if your generative AI has already enough information to be able to generate that synthetic data, shouldn't that be enough? Shouldn't it have enough information to just create a model based on the data that you given it in the
No, that's a different process, and I think you've made it into a slightly circular argument here. So the generation of data is to supplement the training of the model, but if you say I want the model to create a prediction based on generating synthetic data,
no, like more like based on the data they've given me,
yeah,
a model.
Yeah, that's model.
Yeah.
Yeah. So what's the question?
Yeah, I guess like if you are able to go from data to model straight away, then what's the purpose of creating synthetic data?
You don't always need to. I think the synthetic data is if you don't have enough training data to begin with, right?
Yes.
Just to supplement the data set.
To supplement data set, if you want to create a model that can be trained on a certain characteristic of data.
Then why can't you just go directly from the data to the model?
Why not use the original? Why not use the
Next evolution of this.
But why is the model not good enough to train to understand smaller data sets? Why is the model incapable
Okay.
of processing
So
data sets? So that was kind of what I was asking before. I think.
Yeah. So there are models that can create inferences on smaller data sets. The only thing is that if your data set is small, it will end up being a naive model. And that's meaning that it doesn't know the full picture. Imagine the analogy of why can't a kid think like an adult? The young adult doesn't have enough world knowledge yet. So in essence, what you're doing is saying, I am trying to get a kid to learn what an adult knows by doing a matrix style infusion of data, of knowledge into the kid, right? But you need that body of knowledge. If that body of knowledge is limited, right? If you take an adult, let's say the guy that grew up in the jungle, and you have a matrix style disk, but that matrix style disk is a 5-year-old child, and you implant it into that 25-year-old man, what's the logical thing that's going to happen? You're going to have a 25-year-old child, right? So that's in essence why you cannot say, if I can have data of a 5-year-old, and then and I don't have enough data to extrapolate in this case, then you're still going to get the mind of a 5-year-old child. So synthetic data generation isn't meant to say, I want to generate completely new data sets. It has to have a basis of knowledge. And the reason why we can't just go from model to data is because we don't have enough data. So imagine your data set having only 100 instances of a positive outcome and 1 instance of a negative outcome. What's going to happen is that your model is only going to try to find a negative instance when it matches directly with that instance of negative instance. So you need more examples. You cannot have a small data set, too small a data set, because it's not going to learn wide enough. Does it answer your question in a way?
Yeah, the expensive.
Yeah.
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 I'm guessing does that mean it's kind of like saying you're putting a prior onto that data?
Yeah. There it is. It is correct. Yes. So basically, what you're putting a prior, right? So that's basically what it means. You're putting. I think the better term to use a priori. Right? You're saying I'm putting a priori axiomatic rules on data, where I'm doing certain assumptions, and therefore these assumptions build my next data set. Something like that.
Would that be the next step in the evolution of generative AI, generative model generator?
It would be the next evolution. We're not there yet.
We're not there yet, but
Yeah.
that's I'm pretty sure there'll be some company already working.
Of course. The idea of leading edge is the industry is at least 5 to 10 years behind. Yep.
Is there any research on the maximum number of parameters we can train on Gen AI?
Research?
Like anything, like a particular number?
No. The number of parameters is always going to be exponentially increasing. What you can do though is you can apply dimensional reductionality algorithms on that. But there is no limit on the number of parameters. The more parameters, it just takes a longer time to train.
There's no relation between the accuracy and the number of parameters?
No, it starts to plateau at some point. Yeah, you have to find your algorithm. Matt. Yeah.
I want to go back to the discussion we were having before the break about synthetic data.
Yeah.
And I think the scenario you had in mind is a situation where you have a small amount of data.
Yep.
And you create synthetic from that.
Mm.
I think we will start to see more of the situation. The one I see is in health, where you have health who is a custodian for a large amount of data. It is easier for them to create synthetic data rather than to to
Give you permission,
navigate the permission to release that data. So I see that they will start using that. But then that means that the recipient of that synthetic data has no way of validating the data against the original data set, no way of determining the distribution to see how accurate it is. Will we get to a stage where we need sort of marketplace rules? This synthetic data comes with a accreditation or a validation of what it's
Yeah, it's actually a very good point. You need some sort of validation, like you like the lady behind was mentioning. You need some sort of validation, right? Saying like, how do I know this data is correct? But it goes back to the classic machine learning data science methodology. So saying like, does it match the expected distribution? Does it match the expected characteristics? Does it match the expected data formats, right? But it has to come from a bit more research, and you go like, does it look like it's going to be applicable in 5 years' time, right? Because my data set sometimes is used for more than 10 years at a time, and I go like, okay, in 5 years' time, this data set is still going to be applicable.
So it says an expiry date.
Yes, it will have a validation expiry date or like revalidation period. It should actually. That's a pretty good point. Yeah, it should have a revalidation period. Yeah.
A question about the technical architecture that you showed before.
Yes.
So what are the challenges there in part of industry? So security.
Biggest challenge.
Okay. And how about having a sort of constraint that your data can't leave Australia? Because
so here's the thing. People talk about leaving Australia, but a lot of the times your data centers, even when they say Southeast Asia, it's not in Australia, it's in Singapore. So that, and most of the time the data is already in the cloud. It's almost like a patch. The providers will tell you, like, oh yeah, your data will never leave Australia. Of course it does. So, but it doesn't mean that it's bad, because your security policies surrounding that will still accommodate for that. Like it works the same in most architectures, right? If Microsoft's, let's say Microsoft, right? If Microsoft security policies get breached, then everything gets breached, right? So it doesn't matter anymore, right? It doesn't matter if you're in Australia. It doesn't matter if you're within Australia. It doesn't matter, right? Because it's internet anyway. It's people have this romanticized view of Tom Cruise flying through the sky and nah, that's in the cloud, man. Well, you didn't need to do that. Yeah, it's just action. But yeah, it's one of the slight misconceptions in this case of locality of data from this way. They like to do that where your servers live. Yeah, at least in my opinion. Hopefully I'm wrong, because a few implications on that anyway.
I'm going to interrupt.
Yeah.
We're just out of time. We've got 8 minutes left in here, but I just want to thank Sean for his talk. I think it's the most data sciencey talk we've had here this year, but I think you tailored it really well for data engineering, and I'm really impressed with the questions we've got everyone. But I just want to thank everyone for coming on a Friday again. I'm going to be honest, it's the hardest I've had to think at 7 p.m. on a Friday in a while.
I have like 5 years in me.
Yeah. No, thanks, Sean, for coming on, and thanks Inside again. And just remind everyone, like, please jump online to the Data Engineering Bytes website and ask your boss if you can have the day off and permission to attend. We'd love to see everyone there.
Maybe do it at 4 p.m. next time or something.
Yeah. Thanks, Brian. And I'm sure Sean will be here for another few moments before he goes plays poker. If you got any more questions for me.
Yeah. if you don't catch me now, I'll be in the poker tables. Yeah.
Or meet him at the casino.
Yeah.
Thanks, Sean.
Thank you, guys.